All set? Cool. All right, let's kick it off. Thank you all for sticking it out through a very long day. And we'll try to make this shorter than the 50 allotted minutes. I know you've got dinner, drinks, or power naps to get to. But we've got a lot of information to cover. So feel free to just raise your hand, ask questions, interrupt me during the presentation. This will be kind of a rapid whirlwind tour of a lot of different topics. Just so I have an idea who's in the audience, how many of you would consider yourselves a developer of some sort? Okay. How many of you have worked with or worked on web development or worked with web developers? Everybody? Okay. Who's heard of the OWASP Top 10? Great. That's a good start. Okay. So a lot of this will be familiar to a lot of parts of you. Take some notes. I'll have the slides available. Hopefully everyone will take a few very specific things away from this, of things you might not have heard of or might not have considered in that light. But let's dive in. Maybe. Hey. So I'm Fletcher. My company is Hunter2. I'm a walking billboard today. I get called Hunter a lot. That's fine. I have a feeling many of you know the Hunter2 reference in the room, yeah? I don't usually give the full backstory, but it seems appropriate. So very briefly, this is an old security meme back in the days of IRC. Someone said, hey, if you type your password in here, it shows up as a bunch of stars. See? Star, star, star. And someone responded with Hunter2, of course. So that's where we got our name. What we do is secure code training for developers. So we give developers in their browser vulnerable applications that they get to hack and they get to patch up and see hands-on what can happen. So through doing that, we've worked with a lot of results of pen tests, results of red team reports, and bug bounties. Most of that is from teams in sort of the new DevSecOps world of working on frameworks like Node.js code in Express or Rails, Django. You'll see a lot of those things turn up here. Less on the .NET side, Java, things like that. So that's more where my own personal background is, as well as a lot of the focus of this talk. There are a lot of the same topics that will come up in terms of the standard, these guys, the OWASP Top 10, just in a slightly different way. So OWASP Top 10, SQL injection, cross-site scripting, same topics have been recycled, and a lot of these have been around for almost as long as the web. We're going to go through the gotcha top 9-ish, I'm calling it. I didn't really count to be exact. This is not scientific, but just generally the kinds of things that we've seen, how they overlap with sort of OWASP-style topics, and some new topics in there as well. First of all, some motivation. So why does this happen? Like I said, these topics have been around for a long time. We have, generally speaking, good developers who are good at their jobs, but still these things happen all over the place. Rush deadlines. You have to get out code. You might know better. You might not even have a chance to know if it's vulnerable. But if that's your incentive, you got to get it done. And security concerns creep in. Mysterious fixes for mysterious bugs. This is especially true as we keep using newer tools. We're more abstracted away in individual jobs where we're working on a little part of a service. Sometimes, especially with rush deadlines, we'll say, I don't know why this doesn't work, but when I flip this switch, it does. So I'm going to push it out the door that way, without taking the time to get a deeper understanding of what's really going on there and what you might have just introduced as a security hole. Sometimes we just don't know better. Education doesn't really cover this, generally speaking. Most of the time, you can get through a whole computer science course or master's, say, without more than a course in security. Boot camps don't generally cover it. It's up to your employer if they do offer you secure code training. So sometimes developers just haven't heard of this stuff. Or they have and they think they know better. A lot of this comes up because of really bad security education. If I make you watch a video on SQL injection that's 15 years old and has nothing to do with your job, you're probably going to say, oh, that doesn't apply to me, and not worry about it because I'm using the fancy new framework. But, of course, you're still vulnerable, just in more compartmentalized ways. Sometimes we think it doesn't matter, or we're not incentivized to care. Maybe we say, again, I'm working on this one little part of a service, so as far as I know, there's no possible attack vector here. But as soon as I hand this data off, who knows what's happening to it down the line? You really have to have defense in depth there. Sometimes, in terms of incentives, I have written insecure code for folks before. Generally, try to present, these are the risks, this is the trade-off we're making here. But if your management doesn't care, maybe you push out that insecure code. Sometimes, and this is especially true for big companies, requirements just get misunderstood or miscommunicated. Sometimes, it doesn't take someone evil to come up with something evil. They just say, I think this is what was supposed to happen. Or bad decisions get made because I know better, but I have to go within the regulations. And finally, the cult of the new tool. And this is especially relevant to the topic of modern AppSec. Developers jumping on the new JavaScript framework, the new open source library, whatever it happens to be. If you do that and you churn out a project and throw it into production while someone's on alpha release 2 and there isn't really any documentation and you didn't really take the time to learn it beyond the intro tutorial, it can be fun, but there could be all sorts of problems buried in there. That's a more mature framework that's had a lot more code review, a lot more time, and a lot more eyes on it might have caught along the way. Any other thoughts there, or things you guys have seen creep up? Cool. So, without further ado, the gotcha top 9-ish or so. First one, security headers. If you were in Yolanda's talk earlier today, I believe she said of the top 1 million sites, something like 1% use security headers. I might have gotten that statistic wrong, but I believe it. These are some common security headers. There's generally no good reason not to use most of them. So, in terms of your server returning a response, cross-site scripting protection built in for most modern browsers. You include that, they will block it for you. You include that and turn it off, you're bypassing that protection by default. I believe the newest Chrome, last few versions, will block these sorts of things by default now as well. X-frame options against clickjacking. So if you say there are a number of different settings, but if you say, essentially same origin is one X-frame option, that means I can't put an iframe in my site unless it's coming from my site. Or vice versa. I can't put my iframe my site in an iframe. It's been a long day. So, this is for a lot of clickjacking attacks. Someone says, oh, it's your site, but it's really in my site. And go ahead, I'll record everything you're doing in here. Content type options, especially for Internet Explorer. This is where you can do things like, say, I uploaded a text file as an attacker. It's actually an image file or a PDF that can run code. And your browser, as the victim client, will occasionally helpfully guess for you, oh, this is the type you meant, and execute that code for you. The last two mentioned here are, they get asterisks because you might not want to just flip them on without thinking. Newer stuff, relatively newer, at least in terms of usage. Strict transport security means load my site over HTTPS. Load every possible request all the time over HTTPS. Sounds great, except there are kind of no takebacks. So if you get it wrong and you ever need any part of your site loaded over HTTP, you're kind of screwed. So be very careful when turning that on. There's kind of no going back. But if you can get there, it's great. Similar with content security policy. So this is a very configurable policy in terms of allowing you to run scripts or even load images from only trusted domains. The challenge there is modern apps use so many external services and resources that coming up with something that isn't just a blanket star rule is very challenging. So you can very easily break a site by breaking content that should have been loaded into it. Likewise, you can do away with most of the security of CSP by getting fed up and saying, oh, let's just allow all S3 links. Turns out anyone can upload anything to S3, so it doesn't do you any good anymore. Some framework gotchas. So some frameworks give themselves away by adding their own security header. Node does this. They have a little X powered by Node. It's not necessarily a vulnerability by itself, but you're giving attackers extra information. There's no reason. It's also kind of inefficient. It's not that much extra data, but there's no reason to bother sending that kind of header. Particularly for Node, there's a package called Helmet.js, which sets a lot of those defaults for you. One of the things it does is just removes that header for you. Rails, actually, this is one of the few instances where we've got an A+ on the board. Does a really fantastic job of setting great common security headers by default. So props to them. Modern Rails, I'll say. Not necessarily if you use a very outdated version. Particular note about the host header. We've seen this come up in a lot of more, I guess, modern attacks. Similar to every other security rule on the web ever, don't trust user-provided input for anything that might be security-related, or might be run as code, or might be interpreted somewhere along the way. The host header says, hey, I'm coming from, or referring from, example.com. Of course, I can tell you, oh yeah, this request is for example.com, or for whatever else, which can lead down the line to a lot of different vulnerabilities. CSRF, web cache poisoning, password reset poisoning, and lots of other phishing type attacks. Happy to get into the details of what some of those look like. Generally speaking, it means that someone is going, a really common one for password reset poisoning is, as a developer, I say, oh, where can I get the current domain in case it changes? Maybe the subdomain of my app will change. I'll just get it from the host header, and I'll put that into a password reset URL and send it to the user. But if somewhere along the line, say in a caching server in the middle, someone was able to change that host header, you can now generate a link that actually sends you to the attacker's page with the same information. Some framework gotchas. For Django in particular, although some others have similar settings as well, they allow you to do things like set a list, an array of allowed hosts. This is a really common mysterious solution for a mysterious problem, especially for local development. I've seen a lot of developers who will say, I'm trying to resolve localhost, but it's 127.01, and whatever I put in here, it's not working. I'll just put star in allowed hosts, and everything works fine now. Push it out to production, everything still works fine now, especially if I've got some crazy caching going on, or I'm serving it over, Amazon CloudFront stuff. There might be some complex settings to get right there. But if you just put a star, you're opening yourself up to a lot of these types of attacks further on down the line. So a lot of these also come down to trust the settings, use them well, use them smartly, and understand what they're doing, of course. Verbose errors. Turn off debug. Everyone knows it. Everyone has not done it at some point in production. Even if you think that it doesn't seem like you're giving away any super sensitive information, any possible difference from just a very standard blank error page, an attacker can get creative, or code can change, many months, many years from now, that turns that into a possible attack vector. This is really common for sort of a services architecture where things are very API driven. And so a developer will say, I'm just going to pass this whole error to the front end. And that makes its way through 3 different hops to a client, to a user. And besides being a bad user experience, you're giving away lots of extra information based on something that shouldn't have been turned up in the first place, in production at least. Likewise, removing code comments. This is a really common one to see on pen tests of things that don't work. I've even seen being able to search for profanity on a web page. That's a really good ticket into something that doesn't work well or someone is fed up with. This should be part of your build process. You're minifying code, you're stripping out comments as you push it into production. Again, there's no real reason to leave that kind of information in to help guide an attacker along. Some framework gotchas here. Django REST framework in particular, the APIs are browsable. They give you this really wonderful interface where you can just see all the endpoints, you can query there. I don't believe there are any sort of rate limits by default. So you can hit it for days and it'll give you very nice readable format. All your results from a production API if you, as an attacker, go out there and explore it directly. Flask in debug mode, I believe newer Flask, you do need a pin to be able to take advantage of this, but it gives you a console at the bottom of the screen to say, here, help debug this issue. We've brought you the stack trace along with a direct line into the server. So RCE by default there. Rails also very helpfully lets you know all the routes possible. So if you have debug enabled in Rails, if an attacker goes to any page that doesn't exist, it will say, I tried to match against these. Do any of those look interesting to you? Good old Bobby tables, still a problem. Obviously for SQL injection, you should be using the ORM. Do folks know what I mean by object relational mapping, I believe it is? Yeah. So that's Django query set, that's Rails active record, that's .NET has the entity framework. Some abstraction of code around the fact that you shouldn't, as a modern developer, generally speaking, ever be writing raw SQL statements that get run against the database, or worse, that get combined with user input. All of those tools exist in any modern framework. Inevitably, someone will not know a way around how to do their particular kind of wildcard syntax or something. So what if I wanted to? No. There is always a way around it. You should never be writing raw SQL or combining user input with something that could ever be interpreted as a SQL command. Likewise for NoSQL. So MongoDB and other NoSQL stores are getting to be much more popular. The great thing and the terrible thing about them is you can throw whatever you want into it. So likewise as a user, if you say, give me the user where this string is true, I could say with this example where the string user is greater than nothing, which is always true. So that gives me all the users or the first matching user. Very similar, but less commonly seen in terms of the standard lessons to apply. It's just as likely that you'll get hit with this if you have a NoSQL database. A lot of tutorial examples online will try to simplify things by showing basic syntax that is just a raw SQL query. Sometimes don't have enough warnings around never actually do this, or ideally I'd like to see more, here's the correct way afterward with a little more explanation. Likewise in docs, this comes and goes depending on the framework, but usually insufficient warnings against don't write the query this way instead of here are 6 ways you could query a database. 2 of them are terrible. Crosssite scripting, another common one. Standard lessons, most of you probably know this stuff. Don't pass HTML to templates. Sanitize your inputs usually as early as possible. So again, in a services architecture or with APIs or multiple layers of an app where you're handing off data across multiple fronts, be sure to do that as early as possible, because you don't know what else could be done to the data. a lot of the modern issues we've seen with even sanitization libraries are because something got encoded or translated in some way and then stripped. And an attacker was able to say, okay, based on this intermediate step, here's how I can craft something that ends up as malicious code. So that's why you go as early as possible to avoid any of those mix-ups with multiple steps along the way. Cross-site scripting is a great one for modern devs, great candidate for a linter warning to say, automatically as you're writing this code, hey, are you sure you wanted to use this function? Are you sure you wanted to pass data into this template here? This one comes up a lot because of bad naming conventions. So as an example, Django has safe and mark safe, and they're distinctly not that. As a developer who might not have read through the full docs, but just saw, hey, here is safe, I can put my thing in it, and then it'll be safe in a template. You're actually marking, I trust this piece of data inherently as safe, and so I'm marking it as such. I think React was the first to really get this right with the extremely verbose, dangerously set inner HTML. I don't think any developer is going to write that out and be like, oh, this will be totally fine. Yeah, dangerously set it, no problem. XXE, this is a newer one on the top 10 OWASP list. XML external entity injection. The basic idea is you can substitute, you can basically define an entity, substitute the contents of, say, a server file. And as that gets rendered in your XML, you get contents of, some sensitive file that you shouldn't have had access to, typically. Use JSON. That's not always an option, but generally preferred over XML. But of course, that comes with its own dangers. So be careful of any sort of data serialization type of attacks if you are using JSON. This is another one that's really prone to bad naming conventions. It comes down to LXML, I believe, is the C library that a lot of the modern frameworks have their code built on abstractions that use LXML for parsing XML data. And that defaults to being able to resolve those entities. So it defaults to making those substitutions for you. And you have to go in there and say, no, I really don't want the user to be able to do that. libxml.js and a number of other really commonly used packages have this setting that, again, relies on the underlying framework of no ent equals true, which is kind of backward logic. It actually means it will have no external entities because it will replace them for you. So it's completely not what most developers expect, even after reading through docs. No ent means that you'll be able to load in those entities. So be very careful with settings like that. CSRF, cross-site request forgeries. Generally common topic, so I won't go into all the details, but random string gets appended, gets added to a page for, say, every form, every post request, gets changed on every load, so that we know that the user who's submitting this post request is the original intended user who loaded that form in the first place. Otherwise, you could do things like, I make you click a button on my site and it deposits all your money into my bank account because you're already logged in there. I can't do that if I can't guess what CSRF token you're going to use. This still comes up as basically forgetting to add a token somewhere when you have lots and lots of forms on lots of different pages. So one thing you can do a lot of the time is just include it by default. For every page that loads a form, or even every template, have your standard layout say, load in a CSRF token. Now you never have to worry about forgetting it. I would love to see more modern frameworks give warnings when you forget a token. This is another really common one where I'm just trying to get my form to work and it's not, and I thought I included it, but I can't figure out the syntax, so I'm going to turn off that protection. So again, making sure that you use the settings in place and that you use them everywhere it's applicable. authentication authorization. Use strong password hashers. Everyone knows this, but check the docs. Not even all modern frameworks really do a good job of choosing good defaults for you. This is another one where business logic comes in really frequently. So testing all possible scenarios of authentication and authorization, really think like an attacker. Seen a lot of failed tests where someone will say, well, we tried out every possible path. What they really mean is, we tried every path we expected users to take. So as an attacker, can I get creative? Can I use password reset, which is a really common, I don't think I've ever seen a test where a password reset function fully passed, or feature fully passed. Really common one where you might be able to reuse a token, or maybe that triggers something where I can lock a user out of their account, or who knows what else. So a lot of different paths to go down when it comes to creating an account, forgetting a password, and so forth. Flask login is really, really commonly used for Flask apps, and it defaults to SHA-1 as an example of modern apps that have poor encryption that's been considered broken for years. A lot of modern frameworks will also never default your cookies, which is probably not ideal. Obviously, what expiration you put depends on your particular scenario, your business, your app, but you probably want them to expire at some point. And you want to be aware of that. A lot of folks just don't consider it because they hadn't gone in to set those settings. It worked by default. Two flags for cookies in particular, that it makes sense why frameworks don't include these by default, but they're important to know about. HTTP only. I would like to see that included by default in a lot more cases, or at least a warning. HTTP only just means hand this cookie back for HTTP requests as opposed to, say, JavaScript. So if there is cross-site scripting or some other type of attack, JavaScript-based on a client, I can't steal your cookie and hijack a session. Secure just means load these only over HTTPS. Again, might have to set that up in production as opposed to local dev, but whenever possible, makes sense. You wouldn't want your cookies to be easily sniffed. Known vulnerabilities. A big and growing category, I think, when it comes to so much open source. PyPy, NPM, every modern framework now has some sort of open source community around it, building more and more packages every day. There are also a lot of tools and services to help prevent against introducing things that have already been noticed by the wider community. So vulnerability scanners, there are a lot of even free tools. Python has safety as a package. NPM has audit. And by default, when you install packages with NPM, it will now run a short version of that and say, run NPM audit. We noticed some vulnerabilities. Don't ignore those. There might be one or two that are not immediately relevant in terms of it doesn't present an attack surface for your particular app, but make sure you really know that. SNCC, if you haven't seen or heard of them, highly recommend. There's a free version of their tool, and they do a great job of helping collate lots of different open source vulnerabilities to make sure you're not introducing something that someone has noticed. Because when they notice it, an attacker is also looking at that list, and they're going to spray and pray and find as many sites as possible that are vulnerable to that newly popped vulnerability. The best way to prevent this is setting up policies ahead of time. We're all working on rush deadlines. We never have enough time. We engineer things so they take longer than we expect. So the only way that you're going to stay true to what you originally intended is by saying, when we see a critical level vulnerability and so forth down, here are the number of days we'll let that go, or here is the point at which we will let this go to production. Here's the point at which we're going to stop things and make sure that this issue is taken care of ahead of time. Framework gotchas, I just included NPM as a category here. It's been noisy, it's been very active, and it can do a lot of harm. It can do a lot of good too, but anything again that's under very active development where any developer can push to NPM, push to PyPy. A lot of what we've seen more recently is lookalike packages, where someone, it's sort of like domain squatting, where you say, this is the timeit library, but it has an extra T at the end, or there's a slight misspelling, or I squatted on something that you expected to do one thing. It's really doing something different. So you can't necessarily take the time to read all of the source code of all of the open source you're using, sadly. But there is a lot you can do to make sure that you're not introducing those known vulnerabilities and not introducing something that does something other than what you expected or intended. Other stuff, general category. Just some catch-all of stuff that we've seen come up really commonly. Poor password requirements, let your users shoot themselves in the foot. HTTPS or incorrect redirects, enabling HTTPS but not necessarily enforcing it. Poor DevOps, which generally these days comes down to AWS permissioning. AWS docs are notoriously bad, and the setup is very complex some of the time. So that's another case of let me just get it out the door. I'm on day 2.5 of trying to get access to my own app. So let me just, allow access to all on this bucket. And then if that gets into production and stays that way, sometimes that can be very hard to trace back and find the root cause of why that S3 bucket was public or whatever else it happens to be. Open redirects are something that doesn't make a lot of the top lists, it seems, but I've seen come up very frequently. Reverse tab nabbing. Do people know what that is? Some shakes, okay. Idea here is if I can get a link on your site that opens in a new tab, if you don't add a basically no referral attribute, I, as the opened tab, can reference back to my parent. So I can say window opener, I think, and say window opener location is something different, which maybe looks like your original site, but it's not, is my site. So, something that seems very innocuous at first, let me just allow users to provide their own links and open them in a new page, could end up reflecting back on your site. That's one that, gets downplayed a lot, and people don't even realize is possible. And so it comes up in a lot of recent bug bounties, things like that. It can be pretty damaging. Another one that's really common for modern web apps is passing sensitive data to third-party services or even to your own internal services, maybe your newly configured logger, something like that. Maybe your analytics platform that helpfully records all user input and then stores it in the clear and gives it as access to that for your full customer success team, as well as whatever else they do based on the security practices of that third party. So make sure that you have control over sensitive data. Be aware that wherever you have an input field, a user will eventually type a password into it. And so you still need to be able to control and have access to and ideally be able to remove data that's been passed in from a user, even if it gets passed off to a third party. Last one, metadata left in media files. This has been caused some embarrassment for some bigger companies where maybe you leave some information in a PDF document and you allow that to be downloaded. Very easily can be turned up. Who was writing that last, or in terms of social engineering type of attacks, you could find out things like what kind of operating system are they using. Is it out of date? And that could lead to other attacks as well. So make sure you're stripping out metadata. A category for reading docs. This is a whole topic in itself, but hopefully an obvious lesson. Review default configuration. It's so easy to get started up with a new tool these days that it's very tempting not to read the page below the little code excerpt and have your app running and off to the races. A lot of apps or a lot of frameworks will give sensitive settings that are bad by default. Here's your secret key, change this, and then you don't. You can search on GitHub or similar for default secret keys on different frameworks, and you'll turn up a lot of projects that shouldn't have those. Likewise, look for any sort of warning or change this. Go through a Django settings file. There will be a couple places that say you probably want to change this to make it relevant to your app and not reuse this sensitive information. Make sure to do this. So, wrapping up with a prevention checklist. The first step of the list is have your own list. If it's not your own, you're more likely to ignore parts of it. So make sure that everything on the list is relevant to you. Make this for every app, every service that you deploy to production, or possibly every deploy, period. Things like, did we turn off debug mode? How are our secret keys doing? Are they checked into version control? Did we rotate them if needed? All of these things that we've been through, whatever is relevant to that particular app, make sure you go through the list. A checklist can really save the day at the last minute. Use the ORM. Do some basic threat modeling. Again, think like an attacker. See if you missed anything obvious. What would I do if I were to try to maliciously use this application? If you're using open source, make sure that scanning is somehow part of your pipeline, that you're doing that on a regular cycle. Again, maybe that's part of your checklist. Did we scan for open source vulnerabilities? Read through docs, read through default config. And most modern frameworks have some sort of security page or best practices reference. Every so often, read through there. I still go through these pages and see something that I'd forgotten or not known about. So if you're spinning up a new project or you're just deploying something that's been sitting there a while, see if there's anything new there. A lot of good information in terms of common pitfalls can be found on those pages too. Thank you. Slides are available here. They do have large GIFs on them. If you're just free warning if you're downloading over your data plan. And let me know if any questions.
So when you work with your clients, how many QC/QA teams have similar checklists in place and are using them, or if they do, are they robust enough that you kind of get in and find that there's some lacks in coding security among your clients?
Yeah. So what we do at Hunter 2 is the secure code training that's generally on the back end, where we're being informed by other pen tests or other red teams, bug bounties, things like that. And so what's actually more common now is either one-offs of, hey, this happened, and so we're going to email out the team and say, be aware of this. Don't let this happen again, ideally. That doesn't necessarily get embedded into a checklist because it might be a little bit too specific. But ideally it gets embedded as something like custom training that becomes part of an engineering onboarding.
Zooming out then,
Yeah.
Anecdotally, how often do you hear of, because I would imagine that a lot of QC teams are more focused on functionality and then it goes into what it's supposed to do.
Yep.
The enterprise, how often are they incorporating security checklists into their role?
So I don't think specifically a QC/QA team. I don't think I've seen one that has more than a couple random big security topics to check at best. It's usually much more functional. I have seen plenty of teams where security will go through at time of deploy and say, we're going to bring in our own checklist as well. Generally, that's a very painful process, and it's not what you want to aim for, as opposed to modern DevSecOps of, here's the checklist while you're thinking about how to architect this new app. Let's make sure to think of all these problems ahead of time instead of we're rushing to the deadline, we got to get this out, the press release is ready, everyone's lined up, and oh wait, we have all of these security issues now. That's how security becomes not your friend, which is more common, but I have seen a number of teams who, security ideally will come to them with the checklist ahead of time and say, let's make sure. Ideally, it's kind of a choose your own adventure. Like, do you have an authentication piece? Okay, let's go deeper. Do you have this kind of feature, this kind of feature? Now, have you thought about these 5 relevant pieces?
But even when they do it that way, even if they come up front and they say, hey, think about these things as you build, it seems to me there's still kind of a gap on the back here. Where, yeah, I got that.
Well, ideally, and usually this happens, if you're doing that on the front end, you're going to have someone from security go through the same list on the back end and say, okay, how did we turn up the final version of all these things? Cool. Yeah. Is that a question? Okay. Cool. Thank you, everybody.